953, look at the data that you collected for the acute, obtuse, and right triangles. What patterns do you see between the sum of the areas of the two smaller squares and the area of the larger square that formed the triangles in each row? Copy and complete the sentence starters below in your learning log or on the piece of paper that you're using to write your classwork down on. And you're going to summarize the patterns that you see. Title the entry Triangle Side Length Patterns and include some examples along with the date. Well, I've already got my title and my date here, so I'm going to move on. I'm not writing these sentence starters. I'm going to kind of show you the patterns that you should be seeing, and I want you to use your own words to write what you notice and use your own words to describe these patterns and, you know, how we can determine if it's an acute, obtuse, or right triangle based on the sides. So that's what you're going to do in your own words. I'm going to show you, what you need to be getting out of this problem for today. So I'm going to show you how can we determine if it is an acute triangle based on the side lengths. So we need to have, in order to have an acute triangle, we need side A squared plus side B squared to be greater than side C squared. So that just means the area of lengths A and B is greater than the area of length C, which is why you had squares that you were putting together, because area is length times width, and squares are the same on each side. So I'm going to go ahead and show you what exactly this means. So let's say we have a triangle that has side lengths 3, 3, and 4. Now remember, I always need to, my longest side, and in this case is 4, always has to be C. Now my other two are 3 and 3, so it doesn't matter. For the other two, it doesn't matter which one is A, which one is B, as long as the hypotenuse or that longest side is labeled C. So let me show you how this works. I'm going to take this idea here and I'm going to plug all of my numbers in. And remember how important parentheses are. We need to use our parentheses, that matters. So I'm going to have A squared. Oh my, sorry about that, everyone. Okay, so I'm going to have A squared. So, oops, well, A is 3, so it should be 3 squared plus, well, B squared. B is 3 also, so plus 3 squared. It should be greater than the length of C squared, so 4 squared. Well, 3 squared is 9 for both, and it should be greater than 4 squared, which is 16. Well, 9 plus 9 is 18, and 18 is greater than 16. So that's how we tell if our sides that we are given form an acute triangle. So they need to follow this inequality. So the sum of our areas for A and B should be greater than the area of C. Or we could say A squared plus B squared is greater than C squared. Now the A and B, we know C is our hypotenuse. So A and B, those are called the legs of the triangle. All right, let's go ahead and have a look at how we can tell if we have a right angle based on the side lengths given. All right, so how to tell if we have a right triangle. All right, when we have a right triangle, you're going to see something like this. So a squared plus b squared is equal to c squared. And in this case, I'm going to give you an example. So let's say we have the side lengths 5, 12, and 13. So I know that C is my longest side. It has to be. My longest side, the hypotenuse, always has to be C. No exceptions. Not now, not ever. It doesn't matter which one of these is A and B, so let's switch it up and get crazy. Let's call this one B and this one A. Alright, all I need to do now is plug in to this equation here. And let's say, now remember we need parentheses, so A squared, my A is 12, so 12 squared, plus B squared, my B is 5. It should be exactly equal with my C squared, and my C is 13. Gotta square that. Alright, now let's go ahead and square these numbers. 12 squared is 144, plus 5 squared is going to give me 25, and 13 squared is 169. Well, if I add 144 plus 25, I get 169, and that would be a true statement to say that 169 is equal to 169. Yep, always. So, again, this is what we want to be looking at. Now, there are a few ways you could explain this, and you could also use this for your, to finish out your sentence starter if you want. What you could say is the area of A and B should be equal to the area of C. You don't need to do everything that I just, you don't have to do what I just wrote out. You just need to use words to explain. If you want to, you can, but you don't have to. All right, our last type of triangle that we're going to be looking at here is an obtuse triangle. And remember, the obtuse is the triangle that has one angle that is larger than 90 degrees. I don't know why this always leaves residue, but that's okay. We can work with it. All right, so obtuse triangle. How can we tell based on the side lengths? Well, in this case, when we have an obtuse triangle, we're going to have a situation where A squared plus B squared is less than C squared. And give me a second to explain this here. So let's say we have the side lengths 7, 6, and 8. It's got to be C. 8 has to. No exceptions. It's the hypotenuse. Now 7 and 6, it doesn't matter. They're not neither one is the longest side, so either can be A, either can be B. Let's get crazy again and call this one B and this one A. So A squared plus B squared should be less than C squared if we have an obtuse triangle. So let's plug in, with parentheses, A squared, which is 6 squared, plus B squared, which is 7 squared, should be less than 8 squared. I'm just realizing these sides aren't going to work, so let's actually pick new sides here. Okay, so Give me just a second here. We should instead, let's use, oh, let's use 6 squared plus, yeah, let's do 6 squared plus 5 squared. Sorry about that. So 6 squared plus 5 squared. We'll give that a try and see if this works a little bit better. The side lengths that we had would have given us an acute triangle. So for an obtuse triangle, we should have our a squared plus b squared should be less than our c squared. All right, so 6 squared, or 6 times 6, gives me 36, plus 5 squared gives me 25, and that should be less than 8 squared, which is 64. So, gosh, I'm looking up here and I see that I changed the wrong number up here. So my A was 6, my B was 5. Okay. So 36 plus 25 should give us 61, which is in fact less than 64. So again, this is the inequality we need to follow in order to determine if we have an obtuse triangle based on our side lengths. All right. So again, if if you're looking to put this into, simple terms, or, something that might be helpful to remember for writing out, what you could say is, if we're looking at our sentence starter here, it says if 3 squares have sides that make an obtuse triangle, then the sum of the 2 smaller squares, well, here's our 2 smaller squares, and it needs to be less than, so less than the larger square. So really, you don't need to give a whole lot for each of these. I do want to make sure that you understand those patterns. Okay? And, if you have questions, send me an email. I can help. That's all I've got for 9.